In this video, we're going to talk about the precise definition of a limit. The precise definition is the epsilon delta definition. But before we define the limits, it is important to understand the meaning of epsilon and delta. To help us really understand what epsilon and delta means, let's look at a typical limit question. So let's say we have the limits as x approaches 3 of a function 2x minus 1 is equal to 5. If we were to plot this function on a graph, you'd have something like this. This would be your y-axis. This would be your x-axis. So this would probably be the line of best fits. Then you have points of 3 and then point of 5. So this is the graph of 2x minus 1. This can be interpreted as the value of x approaches 3, this function approaches 5. So if you look at the graph, as we are moving towards this side, towards 3, our y value also gets closer and closer to 5. That's the interpretation of this thing. So what does epsilon and delta have to do with any of this? Think of epsilon and delta as kind of like a game. Let's say in the game, this is you and then this is me. In the game, you are meant to give me a range of values for y. And then I am meant to give you a corresponding range of values for x. So the range of values that you're supposed to give me in this game is the epsilon. The corresponding range of values that I'm supposed to give you back based on your y values is the delta. So I'll show you how it works out in this case. So let's say in the game, you ask me to give you the values of x that will guarantee that f of x equal to 2x minus 1 is within 1 unit of 5. This key here, 1 unit of 5. This itself is the epsilon. To find the range within 1 unit of 5, the upper bound of within 1 limit of 5 is 5 plus 1. That means you have another line here. So this line will look like this. So this upper line will be characterized by 5 plus 1. So the lower bound of it would be, so this is the range of values you're looking at, 5 minus 1. So 5 plus 1 and then 5 minus 1. So we know that 5 plus 1 here is 6, 5 plus 1 here is 4. Now, you've given me these values. So how do I find the corresponding x values that tally meets these ones here? So to do that, I'll simply say this would be the corresponding x values, but I don't know what value I have to subtract from here and what value I have to add here to get these two corresponding values. The base idea here is that whatever value I do give you back for the value of x, it should satisfy the condition that is your y value must still be within this range. So the question is, how do I even find those values of x? Let me do a simple arithmetic. I know that my values of y already is 4 is less than f of x is less than 6. So this is my already existing range that it gave to me. So to get my value of x, I simply carry this function and put it in here. So this is 4 is less than 2x minus 1 less than 6. My next target is to make x the only value here. So how do I do that? The first step is to add 1 throughout the inequality. So this will be 4 plus 1 less than 2x minus 1 plus 1 less than 6 plus 1. This is 5 less than 2x minus 1 plus 1 is 2x less than 6 plus 1 is 7. I still have 2x, I have to divide through by 2. So I'll divide everything by 2 here. I divided by 2. So this cancels out this. 5 divided by 2 is 2.5. Less than x less than 7 divided by 2 is 3.5. This is my range of values of x that I have to give back to you. But then remember, you gave me that it should be within 1 unit of 5. So I should give you that it should be within 1 unit or so amount of units within 3. So how do I know the amount of units that should be within 3? First thing I can do is that I can take a higher value. Since this is higher than 3, I'll subtract 3 from it. So I'll say 3.5 minus 3 is equal to 0.5. My response to this game now be that for the value of 3, you should work within 0.5 units of that 3 to still satisfy your range of values of y. This is 3 plus 0.5 and this is 3 minus 0.5. The value I'll be giving you back will be 0.5 units within 3. So here is the meaning of epsilon and delta. Now it gave me a value of 1, be within the range of the limit. So this 1 is the epsilon. That's what the epsilon means in reality. Now I'm to give a value that will correspond to that range for y. So this will be the value of, this is the delta. This is the delta. In cases where you do not give me the actual value, you gave me an epsilon value. An epsilon is a variable. That it can assume any value. So I'll give you back a delta such that for any limit you can solve and get the answer. I'll quickly resolve this in the format where you have the regular epsilon delta definition before I define the epsilon delta definition. Let's clear up space. Let's go back to our game. There are two key inequalities that I can use to get my delta value back from a y value. The first one is that if I have f of x at any point where I have f of x minus L less than, the absolute value of that is less than epsilon. Let's say I do get a value here, that value will be the f of x. Let's say I do plug in a value here and I call it x. So whatever I plug in here and I get f of x minus the L. The L is the value of the limit here. So this is 5. So if I do subtract these two terms, value will be less than the epsilon. That's what this inequality is saying. So this is the first inequality that I have to keep in mind. The second inequality that I have to keep in mind is x minus a absolute value is less than delta. So this inequality is simply saying that if I do have the same property here, let's say this is the x value and this is the y value. So this x minus this value, which is x minus 3 here, will be less than delta. This is just the equivalent for the y values and this is the equivalent for the x values. Let's say in our game, you do give me the y values. So my aim would be to use this inequality and convert it to this inequality. But before I still jump in, let me tell you how the general form of the limit looks like. General form of the limit looks like the limits as x approaches a of f of x is equal to L. So that f of x is this, a is this value here, then L is the sign that the limit is equal to. So I'll rewrite them in this format and then I'll try to convert them to this format. Why am I doing that? To see the value of delta that will give back to you in the game. So this is the absolute value, 2x minus 1 minus 5. Absolute value is less than epsilon. For me, I have 2x minus 1 minus 5 is 6. This is less than epsilon. Now I said the key is to try to make this one look like this one. This one looks like this. On the side, if I write it, it's x minus 3 is less than delta. So how do I get this from this? I factorize 2 out. So this is 2x minus 3 less than epsilon. So that x minus 3 is less than epsilon over 2. So this inequality is likened to this inequality. So at this point, I can now say, okay, you know what? My delta should be epsilon over 2. any value of epsilon you do decide to give me for this limit, the value of delta that I'll give back to you is epsilon over 2. When I do give you back the value of the delta from the epsilon value that you're giving me, you'd have to verify it. You have to verify that the value is true. So how do you verify it? You verify it by using, now in the first place I tried to convert this inequality to this inequality. Now you are going to try to convert this inequality to this inequality. So I'll start off from the beginning and I'll say x minus a is less than delta. Remember, my aim is to convert this one to this one. So this implies that x minus a is x minus 3 less than absolute value less than delta. Delta here is still x minus 3. Remember, I gave you delta to be epsilon over 2. So this is epsilon over 2. Here, since my aim is to make it this way, I have to isolate epsilon. So I'll have to cross multiply so that this is x minus 3 times 2 less than epsilon. I open these brackets to be 2 of x minus 6 less than epsilon. If just so you make 2x minus 6 look like this, you can write minus 6 as minus 1 minus 5. So that you have, I'll continue here. So this is 2x minus 1 minus 5 absolute value less than epsilon. So this is our f of x. This is our L. So here we have f of x minus L is less than epsilon. So now you've succeeded in proving that the value I did give to you is true. So at this point, I think you're ready to see the epsilon delta definition of a limit. For every epsilon greater than 0, there exists a delta greater than 0. So the equivalent delta that will correspond to the epsilons here must also be greater than 0, such that f of x lies within the epsilon units of the limit L whenever x lies with delta units of a. So what all of this is saying is that when you have a range of values for epsilon, and I do decide to give you a delta value that falls within a particular range for this, from this point. So if I do decide to give a delta value, if the delta value is correct, then any number between here and here, or any number in here, should still fall within this range. But if we start having numbers outside of this range, they will not fall within the epsilon range. So that's just the idea. Whatever epsilon value you give me, I can use a delta value that will still fall within the same range of that same limit. So in this case, like we solved before, if I use 0.4 for delta, it will still satisfy the epsilon value. So I have to pick values of delta that are less than 0.4. But if I do decide to use 0.6, to not fit the epsilon range, it will not fall within the epsilon range for this particular value. If I do decide to use 0.3, it will fall within the epsilon range for this particular value. Range of values for f of x we are looking at here is 4 to 6. So one last thing, the definition is written out in mathematics. You'd see it as like this. So this symbol means that for all, so this is saying for all epsilon, or for every epsilon greater than 0, there exists a delta greater than 0. So it's basically from here to here. This is the compressed. So in mathematics, they write it like this. So this symbol is for all epsilon greater than 0, there exists a delta greater than 0. So we just wrote this whole thing from here to here in this short form. So such that the f absolute value of f of x minus L is absolute value of less than epsilon whenever we have the absolute value of x minus a less than delta. So this is how we derive steps in mathematics, but this is what it says, and this is what it actually means on a graph. Here's how to define limits. If you like the video, subscribe to the channel. It really helps me. Share with your friends and click the like button. Thank you very much.